So this is where everybody wants to pause. Well, I mean, I'll maybe run through these first, and then you guys can pause and write them all down. On a test, you guys can have these. Okay, you can have it. Actually, on the quiz that I have them all up in the corner of the quiz.
Cool.
Okay. Now, a lot of these are common sense. I was mentioning yesterday, if you had something like a summation of 4, as I goes from 1 to 3, think about what you would write down. You would write 4 plus 4 plus 4. Since you don't have an I in it, you're never like putting anything in there that changes, but you do have to write it n times, so it's just C times n. Okay. This is telling you if you have a coefficient in front of something. Like if I would have had 3 times 2 to the I, instead of writing 3 times 2 to the 0 plus 3 times 2 to the first plus 3 times 2 to the whatever, I could have, yeah. Mm-hmm. So if you can factor it out of the sum, you can actually pop it out of the sum this way. This is saying that the sum or the summation of a sum of 2 functions of I equals the sum of the summations of the functions of I individually, and ditto for the difference. So you can just write, when you guys are writing this down, you can just write it with a plus or minus and just write it once. These are the formulas I was talking about with, I'm pretty sure it was Gauss that did that little number trick to annoy his teacher. And so this is the shortcut for adding, if you wanted to add the terms from 1 to 100, instead of adding them all up, you just go, okay, my n is 100. So I would go 100 times 101 divided by 2.
At least from sorry.
No, go ahead.
At least from a fundamental standpoint, the 4 on the left look a lot similar to the logarithmic properties and theorems.
Yeah, except
kind of.
the sum going to a sum. That would be like a product.
Like thinking of splitting them.
Yeah.
At least, yeah.
Looks probably exactly like one thing that you guys did this year. The properties are exactly like, what did you do that's new in calculus? I'd say it's probably new for you in calculus. Tangent. So, where did that slope of that tangent line originally come from? A funky formula with an H in it that had what in front of it? Limit.
Okay. Yeah.
Yeah, I'm jumping in too fast. But yeah, these are the same as your limit properties. Mm-hmm. The limit of a constant is a constant. Now, I mean, this has an n in it, so that's different. Yeah. But the limit of a coefficient times something is just you pop the coefficient out. The limit of the sum of 2 functions is the sum of the limits. Same with the difference. Okay. This is your formula for the summation of I squared. This is your summation for the formula of I cubed. Usually, a lot of times you'll see this one over here with this one. So it's like constant I squared, I cubed, and that's it. Okay, so again, go ahead and write these down. When I do this one, actually that's not how I would write it down. And I don't know why I've never changed this. Not that that's wrong, it's not wrong. But I write it as n squared, n plus 1 squared over 4. It's just like a little bit less work whenever you're doing the substitution step. Okay. All right, pause, write them all down if you didn't get it. Okay, somebody want to try one of these?
Sure.
And you don't have to use anything that was on the last page for that. You don't, because you're just going from 2 to 5. Those things from the last page come in handy when you're going from 1 to 50, 1 to 1,000. That's when you want to use generic n's and then plug them in later.
Okay. So I, J, and K are common index of summation.
Yes. Okay, that's very good. Yay! Okay, so the question was, or do we want to do this first? Because that's a really cool question, from 2 to 50. And the beginning of this is going to be worse than the rest of this, whenever we try to do 2 to 50. So this, can you guys write this using summation notation?
Oh, okay, it's just going backwards.
Yeah, you just want to write this as some sum. Okay. S-O-M-E-S-U-M.
Okay, I see. Starts here.
Starts at 1. Now, does it matter which variable we use?
Nope.
Okay.
I mean,
Yeah,
you could
'cause-
even use,
Oh, cool.
like not. I mean,
Yeah,
you could
okay.
use X if you want, but it's just really not common. It's
Okay.
Yes.
Yay, good.
Cool.
Wow. It shows you how it can be literally anything. It could be in a fraction.
Yeah, that I can be anywhere.
You can do really anything.
To the something. Could
Uh-huh.
be a square root.
Yes.
Square root of the natural log of.
Mhm.
I
But-
was giving cube
But
or
in
something,
those types of problems, you wouldn't see them in a ... form where you have a ton of them, because you can only simplify, like we're going to do this one up here.
Okay.
You can only use those properties to simplify very simple polynomial functions of I. Things that end up involving a constant or an I to the first, I to the second, I to the third. You can grab that.
Okay.
Okay, so with the 50, the first thing you
You're
want to
still
realize is that to use these things, which I want to use, we have to start at 1. So because I'm going from 2 to 50, that's the most interesting part of this whole thing. I have to figure out how to rewrite this, either to go from 1 to 50 and like revamp that a little bit,
Can't you?
or to go from 1 to something else.
Sorry.
Yeah.
To go from 1 to something else. Like instead of 2 to 50, I could go 1 to, what do you think?
What if you just 1 to 15 took the first term out when you were done?
We can do that.
Oh yeah.
You want to do that?
Mhm. It's
Okay.
probably the least amount of work.
So
It really is.
do you?
I could've-
You can distribute
Yes.
or FOIL that.
Perfect.
Mm-hmm.
2K.
Minus 3. That's going to be easy to plug
Okay.
in.
80s,
yeah.
90s, 2K today.
Okay, so now what we want to do is use the property that says the summation of a difference equals the difference of the summations. At the same time,
Okay.
when I separate these three, for this one has a coefficient in front of the k, so I'm going to pop that out. Okay?
Okay.
So this is going to equal, that's
The
going to
summation of 1 to 50. Okay, and then minus. Pop that 2 out in front.
Uh-huh.
Yeah. So how would you
Minus.
Now, this is up to you. I'm going to leave the 3 in. When we do this stuff, when we're trying to do those, like finding the area under the curve, a lot of times people will pop the 3 out and leave a 1 in there, which seems weird too.
the
So it
summation
really doesn't
of
matter.
the constant though would be the constant times 50,
Uh-huh.
right?
Right.
So couldn't you just put? Okay, wait. That we'll say that for the next step.
Okay. Great. So now I'm going to do this. This was, and you guys look at your notes if you need to. So the summation of I squared is n times 2n plus 1 times n plus 1 all over 6. Okay, it's just
Yeah.
something
Mhm.
to look at until you accidentally memorize it. Or
Right.
I don't want to use green. So this is going to be, if we could put in our n's now, right? Because we know what n is.
That n is 50.
Mm-hmm.
Okay,
So
50 times
2n
51.
plus 1. Well,
Oh,
either
it
one.
doesn't.
There's the n plus 1, and then there's the 2n plus 1.
Right.
Over 6.
Over 6
Mm-hmm.
minus 2 times.
And then it's supposed to be parentheses. I'll just put that 2 up there with the rest. Okay, n
2 times 50.
n plus 1
51.
all over 2.
All over 2.
Yep.
Okay,
Okay, we're getting something.
and
And then 150.
Perfect.
Or wait, let's write it.
Want to write it like that?
Yeah, n times
Mm-hmm.
out of the constant times n.
Right. And then we do have to remember to go back and take out the 1 with the 1 because we were only
Yeah.
supposed to go 2 to 50. Okay, so can we do some whole canceling here?
Oh, I was just. I don't know if I said this because I was just interrupted.
Ugly looking, but that's it.
Okay, cool. Oh, and now, he is
you
going
have
to take care of it, right?
I'm just going to get rid of all of this. Is there a button up here? Or?
You can. Where's your
shrink
trash
it.
can?
You can shrink it.
Okay.
You can use the X and drag it to the. Oh, I'm surprised that worked.
I don't know if I grabbed it by the actual.
By the handle, it doesn't matter.
Up. That, okay. So for the first one, so it's, I'm just going to do 1.
Okay.
In this case, squared minus 2k minus 3. So this ends up being 1 squared minus 2 minus 3.
-4?
So,
And don't you subtract that?
Yeah.
So you would be actually adding it?
there we go.
Yay. Okay. Want to see a cool thing? Should I show you something with the calculator?
Sure.
You're going to use the catalog. You go to catalog.
Oh, that's right.
And then T, because it's so far down that I'd rather back up.
Oh, yeah.
Yeah.
Okay.
And there are so many S's.
Yeah.
There.
So you do the summation.
Ooh,
Oh,
this
you're
is
in
math
math view.
print, this is it.
That's so much easier in math print.
Oh.
Instead of having to do like n deriv something comma something comma something.
Yeah, well this is, okay,
You
so
just,
this is a no-brainer. I know you guys could do that from here.
Yeah.
Let me just show anybody who doesn't have math print, because that might, I don't know if here's what I'm used to. Some calculators don't have summation. So I'm used to doing sum. And if you do sum, then you also need, and now I'm going to go to F. Oh. Now I'm going to go to, I don't know why I wasn't in the catalog. Now I'm going to go to sequence. So I just hit S.
Sum of the sequence.
And I want the
of,
lowercase, sum
Yeah.
of the sequence of, and then what do I have here? K squared minus 2k minus 3 with respect to k, or tell it my variable's k,
comma
from,
1.
1,
Comma.
oh wait, no, I
Two.
wanted,
2 to 50,
yeah,
and then in parentheses, and we
And
should
another
get
and, and
Yeah.
parentheses,
bam.
Beautiful,
Simple as that.
yes.
I still like the math print easier.
Wow.
Easier.
Oh yeah,
but-
that, well, and the
Me
fact
too.
that you guys have a summation command, I don't have that on my 84.
Yeah.
My TI-84 does not have summation because I haven't
You mean
updated the
this?
OS.
Or you mean your
I don't
actual
know,
hard
but
copy?
my ones that I
Oh,
have.
you should update the OS.
Okay, you guys want to say bye?
Alright.
Alright. Bye, everyone. Hope you have
Bye.
a
I was like
great
leaning
time.
in to say bye on the laptop, and you like turned it, so it looked like I was like sideways.
Oh yeah, let's do some artistic.
You're
probably not.
And we are going to flip this class.
Oh!
Oh, wait,
we
how did it do that?
Apple ingenuity.
Whoa.
What?
Oh my god,
It
it
doesn't-
saved.
Wait, we were right side up, and
The
then we
whole-
turned, and then we were still right side up.
You turn it halfway and it goes up 180. That's why. It turns
Oh.
twice as far as
Oh wait, no, we're technically are upside down.
Are we?
We're stupid. We're stupid. The laptop's upside
We
down.
have to
and
leave
we
a lot of this in.
We look right side up because the camera.
Yeah.
Oh my gosh, we're stupid.
So we were upside down the whole time?
Yeah. If it flips
Well,
us upside
we
down,
saw
then.
ourselves upside down, so that it was right side up.
Oh my gosh.
Wow.
We're
where's the
actually
pen?
retarded.
Did I
right
lose
there.
We're
the
like,
pen?
oh my gosh, it flipped us. And no, it didn't.
Oh, well, never mind. Okay,
Looked
so
like
I'll
it
go
did.
It would
over here.
obviously look like we were up. It would obviously look like we were right side up. Oh, do we still have to do?
No, we're not. Well,
I wonder what it'll look like on the video, since you won't
okay.
actually be seeing
So
it
from
now.
here, you know what I can do? I could do this in, help me out, Educreations. I'll just
Okay.
write this one down in Educreations and I'll put it up there. Or Nomia or something.
And
And there's your homework. Okay, so we're all good.
Whoopee.
Okay.
Done.
And we already said bye. Do you want to say hi,
To who?
Mrs. Tabana?
Oh, it's
Who
just
am
a
I
video.
talking to?
Well,
Hey,
you're talking to the rest of my
Picard.
class. Okay, bye.
If we even have time